James Webb pointed at the early universe and found black holes that should not be there yet. Not bigger by a little, not slightly ahead of schedule, engines already heavy when the cosmos was still a toddler. Compact red sparks, so small on the sky that researchers started calling them little red dots, and once the spectra opened, those dots stopped looking cute. Many of them looked like young supermassive black holes wrapped in dense glowing cocoons, feeding hard while the universe was only hundreds of millions of years old. If that reading holds, you are staring at a production line. Nobody put on the public brochure, Hidden Era of Black Hole Growth, shortcut that makes the slow, polite path look incomplete. That is the discovery, and it begins with a color that refused to behave. Before Webb, the early universe was supposed to be quieter. Stars assemble, galaxies grow, black holes start small from the corpses of massive stars, then eat and merge for billions of years, until they become the monsters that sit in galactic centers today. That story is clean. That story fits textbook. That story also assumed our old telescopes were seeing most of the relevant action. Webb was built to look deeper in infrared, gold mirrors, cold orbit, sensitivity aimed at faint unseen light. Within months of science operations, the images started returning a population that surveys had not prepared people for. I'm red, abundant, sitting at distances that mean we are looking back to a time when the universe was young enough that polite growth should still be struggling. Astronomers named them little red dots because the nickname sticks and because the objects look almost point-like, ball on the sky. Red in the rest frame optical, easy to scroll past if you want a pretty spiral, hard to ignore once you count how many there are. At first nobody agreed what they were. One camp said extreme star factories packed so dense they would break records for stellar density. Another camp said active black holes reddened by dust and gas. Third camp said both could be hiding in the same sample because the early universe does not owe you a single species. The fight was not aesthetic. The fight was mass and time. If these are black holes, already millions of suns heavy in a universe that young, then the growth clock is wrong, or the seeds were never light to begin with. Follow-up spectra started swinging the room. In large samples drawn from deep Webb surveys, a striking fraction showed gas racing at about 1,000 kilometers per second. That speed is the signature of material whipping around near a supermassive black hole. Broad hydrogen lines, disk kinematics, the kind of fingerprint you expect from an accretion engine, not from a calm star cluster. Roughly 7 out of 10 targets in key spectroscopic follow-ups carried that mark. That is not a rumor from one weird object. That is a population whispering the same dirty secret. Here is the part that makes the clickbait honest. These sources are common compared with the classic ultraviolet quasars at similar ages, orders of magnitude more common in some counts. The bright blue quasars were the celebrity. The little red dots look like the underworld. Obscured, compact, loud in optical lines, quiet in X-rays, quiet in radio, wrapped so thick that the usual high-energy screams get muffled while the optical glow still escapes as a red bruise. Picture the scene without a diagram. Young black hole sits inside a cocoon of ionized gas, only light days across. Material reigns in near the Eddington limit. Electrons scatter light, lines broaden. The cocoon reprocesses energy into the red continuum that made the nickname. From Earth, you see a tiny red spark. Up close in physics, space you see a newborn engine trying to become a galaxy heart before the galaxy itself looks finished. That cocoon story matters because it also explains why the monsters looked even more impossible at first. Early mass estimates from broad lines sometimes pushed black hole masses absurdly high for their host stars, of a massive n times heavier than the local black hole to galaxy ratio. 100 times in the wildest readings. Headlines loved that. Theorists sweated. Then higher quality spectra suggested something quieter and still shocking. In many of the best studied cases, the broad wings are dominated by electron scattering around a narrower core. Recalibrate carefully, and the black holes can drop by about 2 orders of magnitude. Still in millions of suns, still early, still hungry, but now they look like young seeds racing rather than finished titans teleported into the dawn. Young does not mean harmless. Even at the lower masses, the timing problem remains. Light seeds from the first stars begin maybe up to about 1,000 suns. Then they need mergers and feeding without long quiet gaps. Every doubling costs a clock. At look-back times of only a few 100 million years, that clock gets short. Heavy seeds from direct collapse or supermassive star collapse start already huge. Super Eddington feeding for brief violent chapters can also biomass faster than the polite limit. Little red dots sit right on that battlefield. They may be the missing middle chapter between seed and celebrity quasar. Webb also caught individuals that refuse to be polite. There are cases near 1.5 billion years after the Big Bang, where a black hole appears to be accreting above the Eddington rate. Super Eddington feeding so hard the radiation pressure should push back, and yet the flow keeps coming. That does not prove every early black hole cheated. It proves cheating is allowed by nature in short, brutal windows. Once you allow those windows, the early monsters stop looking like magic and start looking like physics under pressure. Zoom out to the census that made researchers raise their voices. Little red dots appear in force around 600 million years after the Big Bang. Then they fade hard by about 1.5 billion years. They do not linger forever as a permanent fashion. They arrive as a chapter. They leave as a chapter. If most of them are growing black holes, the chapter is an era of obscured assembly. Time when the dark engines put on weight behind curtains of gas, while the rest of the sky was still learning how to make ordinary galaxies. That rise and fall is the kind of plot twist surveys dream about. Emergence, peak, decline, temporary species in cosmic history. Not a forever population phase. Why should you care if you will never reduce a NIRS spectrum yourself? Because the origin of supermassive black holes decides whether the first billion years is merely surprising or structurally incomplete. If obscured rapid growers were common, then the famous early quasars are the tip of a buried iceberg. If they were rare, then every overmassive claim becomes a tighter puzzle about measurement tricks and selection bias. Little red dots force the question into the open, because they are too numerous to dismiss as one broken object and too strange to file under business as usual. Imagine what it means for the slow path. The slow path says wait as a star. Leave a remnant, merge, out. Wait again, build a galaxy. Park the black hole in the center like furniture that arrived with the house. The little red dots say maybe the furniture arrived first and the house grew around the hunger. Dense gas, compact hosts, black holes that look heavy compared with the stars around them. Reversed hierarchy that makes your intuition itch. Some teams still defend extreme star formation for part of the sample. Fair, dense stellar systems can fake some signals. The early universe is allowed to be plural. The strongest claim is not that every red spark is a black hole. The strongest claim is that a large fraction behave like accreting engines, and that fraction is big enough to rewrite the growth budget of the dawn. Caution is not the enemy of the story. Caution is the adult version. Masses from lines can lie. If scattering dominates, dust can redden. Without a monster, ray quietness can mean heavy obscuration or a different engine. Radio silence can mean youth or muffling, or both. Peer review will keep chewing. New surveys will reclassify some dots into other species. That is science doing its job. It does not erase the core shock. Webb revealed a crowded red underworld at early times that older telescopes were not built to count. Hold that next to the public promise people heard before launch. Webb would find the first galaxies. Webb would settle how structure began. Instead, Webb keeps returning exhibits that force theory to sweat. Early bright systems. Strange, compact red sources, black holes that look too ready too soon. The telescope is not breaking physics. It is breaking the comfort of a single, clean timeline. Feel the scale without drowning in jargon. 1 million solar masses means 1 million copies of our sun, crushed into a region so compact that light near the edge can barely climb out. Put that engine inside a cocoon only light days wide, and you have a furnace the size of a solar system neighborhood wrapped in fog. From 13 billion light-years away, that furnace collapses into a single red pixel on a detector. That pixel is why the nickname sounds small. The physics behind the pixel is not small. Now, picture the river of time, 600 million years after the Big Bang. is not forever ago. In a poetic sense alone, it is early enough that many people still imagine empty dark and a few lonely first stars. Instead, the infrared sky is dotted with compact red engines. They flash through a chapter, they thin out. Later, the classic quasars dominate the celebrity lists. The underworld may have fed the celebrities, or the underworld may be a parallel channel that mostly fade. Either way, the brochure version of Black Hole Childhood just got rewritten in public data. Here is a quieter lesson under the fireworks. Nobody needed a private prophecy to find these. The dots were sitting in deep fields waiting for mirrors cold enough and software stubborn enough. Researchers named what they saw because naming is how humans refuse to scroll past weirdness. Curiosity plus pattern recognition plus the nerve to ask for spectra. That is how an impossible population becomes a paper, and then a crisis, and then a research program. Walk through the measurement the way a detective walks a room. First, the photometry. Filters catch more light in redder bands than a normal star-forming galaxy at that distance would prefer. The object is compact, almost to the resolution limit. Then, spectroscopy. Hydrogen lines stretch wide. Helium joins the party in some cases. The continuum shows a break that looks like a Balmer feature carved by dense gas. Stack those clues and the room stops feeling like a dusty starburst alone. It starts feeling like an engine wrapped in fog. Now add the absences, because absences are evidence too. Chandra and other X-ray telescopes often see nothing where a naked quasar of similar optical power should scream. Radio arrays often hear quiet. That silence used to be a reason to doubt the black hole reading. The cocoon model flipped the silence into a prediction. Thick ionized gas and dense columns can smother high-energy photons and quench jets while still letting reprocessed optical light leak out as that stubborn red glow. What looked like a contradiction becomes a costume. There is another twist that keeps honest people awake. If you take the broadest line widths at face value, you can invent black holes that outweigh their host stars by ridiculous factors. The local universe has a rough ratio. Early little red dots seem to smash it. Either the early universe grew black holes first and stars later, or the ruler was lying. Newer work arguing for electron scattering around a narrower intrinsic core is the ruler fight. It does not make the objects boring. It makes them young instead of absurd. Jung still breaks the brochure. Absurd would break the calculator. Hold the single object in your mind the way the infinity story held a single wreck. Somewhere in a deep field sits one red spark, light that left when Earth did not exist and the sun did not exist. When the Milky Way was not a spiral postcard, that light crosses almost the entire age of the cosmos and lands in a detector colder than winter on a mirror coated in gold. Woman opens a plot, sees a line wider than weather, writes a paper, argues in a conference hallway. That chain from foggy engine to slide deck is the real miracle of the decade. And it is happening over and over because the dots are not one celebrity, they are a crowd. Crowd changes everything. One impossible black hole can be a bad math. Crowd with the same red compact look, the same early ages, and the same broad line fraction is a demographic. Demographics rewrite history. They say this was not a fluke collision of numbers. This was a mode where the universe assembled darkness while the rest of structure was still under construction. Compare that mode with the celebrity quasars people already knew. Ultraviolet selected quasars are the stadium lights. Rar, blending, easy to find once you know the color cut. Little red dots are the basement clubs. Harder for old surveys, easier for Webb. More numerous in the early chapters, possibly the feeders that later become the stadium acts, or possibly a side branch that mostly burns out. Either fork matters. Knee fork means growth was hidden. The other means growth had a temporary fashion that died. Both forks are more interesting than the staircase story. And then there is the human scale of why this feels like a plot twist. For a century, black holes moved from math to suspicion to photograph. The first image of a shadow, the first rings of light, those were victories of the nearby And the massive web dragged the argument back to childhood, not how a finished monster looks, how a monster starts. Childhood is where theories hide their weakest assumption. Childhood is where shortcuts live. Childhood is where a red fog can disguise an engine until an infrared telescope finally counts the disguise. If you want the emotional version without lying, it is this. The early universe was not waiting politely for black holes to grow up. Something in that fog was already clocking in for overtime. Webb did not invent that overtime. Webb made overtime impossible to ignore. So, what did James Webb really find about black holes? Not a single magic monster with a movie trailer class. Red compact class at early times, many showing gas racing like an accretion disk, many quiet where old black hole hunters expected X-rays, many living through a rise and fall that looks like a hidden growth era. Some feeding above the polite limit, some looking overmassive until better spectra pull the masses down and still leave them young and dangerous. Picture that makes direct collapse and Super Eddington chapters feel less like whiteboard fantasies and more like options the universe actually used. The debate is not over, it should not be, but the sky already moved. The early universe is no longer a polite staircase of light seeds climbing for eternity. It is a construction site with shortcuts, fog curtains, and engines that clocked in before the building looked finished. Point at the little red dots, point at the broad lines, point at the missing X-rays, point at the chapter that appears around 600 million years and mostly vanishes by 1.5 billion. Somewhere in that fog, if the spectra keep telling the same story, the cosmos showed us how black holes can get serious, while the rest of creation is still learning its name. Thank you for watching.